Hi, kids. Okay, another circular motion problem. We have a car traveling 20 meters per second. It's trying to go around a corner with a radius of 35 meters. And you might think, well, that's big. But if you think, going around a turn, you want a big radius. If the coefficient of static friction is 0.8, will the car make the turn? And then how do you know? Okay, so as always with this unit process, step number 1 in 3D. Is to draw your free body diagram. So here is my car. Force is acting on the car. Let's say the car is going to be turning to the right. I have the normal force up. I have force of gravity down. And then towards the center is your force of friction. Okay. Now, if you're not sure about this, think about driving your car in the wintertime. Hopefully you've never had this happen, but unfortunately I have had it happen. In the wintertime, if it is really ridiculously icy and you go to turn your car doesn't turn, it goes straight because of inertia. So what is causing it to move in a circle? Well, friction is. Friction is your centripetal force. Okay? So first step is here. Also remember the reason it's called static friction. There would be like kinetic friction, but if my car is going this way and then turning right, the kinetic friction is coming like out of the board like this. Static friction is keeping the car from moving outward, okay, it's keeping it moving in a straight line, or from like that. But anyway, but that's why we are talking about static friction, not kinetic friction, because kinetic friction would be pointing like out of the board this way. But anyway, all right, let's do our two equations as we always do. So I'll call this my y, I'm going to get Fn minus Fg, and as always that equals 0 because my car is not accelerating in or out of the road. My other equation is Ff, and that equals mac. Remember it's the centripetal acceleration because it's moving in a circle. So I come here, I get Fn equals m times g, which is 1100 times 9.8. So my Fn equals 1100 times 9.8 is divided 10780 newtons. And then over here, I'm going to get Ff equals m, which is 1100. Remember, this is v squared divided by r. So I get v squared, which is 20 squared divided by my radius, which is 35. Okay, and I get times 20 squared divided by 35, I get all right, so I get this big number, newtons. What this means is I have 12,500 or so newtons available to me to make it around that's how much I need in order to make it around the circle. So my next thing I have to do then is see, well, do I actually have this many newtons in order to make it around the circle? So if I do my math, I know Ff equals mu Fn. And if you look, I can already tell, yeah, I'm not going to have enough because if you go 0.8 times this, you're not going to get this. So my car is not going to make it around the circle, so my car is going to just keep going straight and wipe out. Bad news. You're going too fast around that corner, which is why, if you come up to a curve, it actually says, speed limit 40 miles an hour because of this, okay? But let's say there was an additional question that said, you know what? Well, I know I'm not going to make it around the turn. What's the fastest that you could go to make it around the turn? Okay, in order to, what's the fastest you could go? So if I wanted to set up a speed limit sign, what would it be? Well, so then let's do that question. So I'm going to say, well, Ff equals 0.8 times 10780. So the force of friction I have available to me is this, 8,624 newtons. So then, if I plug that in over here instead, and I say, okay, so my FF is going to be 8624, My mass is 1100. V is what I'm looking for. My radius of the turn is 35. If I do my math, I get that my top speed would be 16.6 meters per second. So if I was putting a speed limit on this curve, it would probably be something like, because this is about 35 miles an hour, so you'd probably want to go less than that because everybody speeds, so you'd probably say like 25 miles per hour. But that would be the maximum speed you could go to safely make it around the turn. Bye, kids.